Hello, everyone. Welcome back to Books and Beyond. Today, we're looking into the intriguing world of mathematics. Why is zero greater than nothing? Let's embark on this numerical journey and unravel the mystery together. I was actually one day sitting in the living room filming my father as he was reading the newspaper, and he all of a sudden said, "Is zero greater than nothing?"
You know that zero is more than nothing? You are a mathematician. You know this? That zero is more than nothing? Yes. That's what I have to say for today.
Let's look at a brief history of zero. Where did zero originate from? The concept of zero as a placeholder was first used by the Sumerians in Mesopotamia. They developed a counting system using positional notation, where the absence of a value in a digit place was marked by a space. The Babylonians, around the 2nd century BCE, inherited the Sumerian system using a placeholder symbol, a pair of slanted wedges, to indicate the absence of a value in their base 16 number system. We then move on to ancient India, where Brahmagupta, around the 7th century CE, the Indian mathematician and astronomer Brahmagupta is often credited with developing the concept of zero as a number. In his work, Brahmasvuta Siddhanta, he described zero as a number that results from subtracting number from itself, and he formulated rules for arithmetic involving zero. We then spread it to the Islamic world, where Al-Khwarizmi, around 9th century CE, the Persian mathematician, played a significant role in spreading the concept of zero to the Islamic world. His works on algebra and arithmetic, which included the use of zero, were later translated into Latin and introduced to Europe. In the 13th century CE, Fibonacci, the Italian mathematician, introduced the Hindu-Arabic numerical system, including zero, to Europe through his book Liber Abaci. This system gradually replaced the Roman numerical system, which lacked a zero. Zero became an integral part of the number system used worldwide today, essential in mathematics, science, engineering, and computing. So let's go ahead and look a little bit at why is zero greater than nothing. Before we investigate into the comparison, let's quickly refresh our understanding of zero. In mathematics, zero is a unique number. It's the point on the number line that represents the absence of quantity. Now, what about nothing? It's a bit more abstract. Nothing is the absence of value, a conceptual void rather than a numeric point on the scale. So, is zero greater than nothing? Let's think about it. When we compare zero to nothing, we're essentially comparing a defined numerical value to the absence of any value. Logically, something represented by zero seems greater than nothing, which lacks any specific representation. Now, let's look at a number line. Imagine the number line. Zero has a clear position on it, right between -1 and 1, but nothing doesn't. It's a concept without a specific location in the numerical landscape. If I said, can you point to nothing on the number line, where would you point to? Now, let's touch on the philosophical side. Does nothing have any quantifiable value, or is it more a philosophical void? The answer may vary depending on how we interpret and conceptualize these terms. For instance, an empty set in mathematics is often denoted by the empty set symbol. Empty sets are sets with no items or elements in them and is also called the null set. In the realm of mathematics, zero plays a crucial role in equations, limits, and calculations. It's a placeholder, a reference point, and a vital component in various mathematical operations. Nothing, on the other hand, doesn't quite fit into these mathematical frameworks in the same way. What's the difference between dividing by nothing and dividing by zero? Dividing by nothing and dividing by zero might sound similar, but they're quite different concepts in mathematics. Dividing by zero. This is a well-defined mathematical concept that is actually undefined. When we try to divide any number by zero, the result is undefined because you cannot distribute a number into zero parts. For example, we could turn a division problem such as 24 divided by 6, and instead I can ask the same question such as 6 times what number is 24? For example, using the same logic, 24 divided by 0 has no meaning in standard arithmetic because there's no number that you can multiply by 0 to get 24. This leads to a mathematical inconsistency and is therefore considered undefined. Einstein once famously said, "Black holes are where God divided by 0." Dividing by nothing, on the other hand, this phrase is less precise and not typically used in mathematics. However, if you interpret nothing as having no divisor, then it might mean the operation is not performed at all. In practical terms, it could imply that the division operation is not applicable or has not been specified. In summary, while it might initially seem like a paradox, 0 is considered greater than nothing because 0 is a defined numerical value, a point on the number line, and a placeholder in mathematical operations. Nothing, in contrast, is more of a conceptual void without a specific numeric representation. Well, I hope this exploration has shed some light on the curious relationship between 0 and nothing in the world of mathematics. If you enjoyed this video, don't forget to hit the like button, subscribe, and if you have any thoughtful comments below, until next time.